Okay, so in this lesson, we're going to try to figure out something about the properties of water. Water self-ionizes. So does that mean water reacts with itself? Yeah, it does. It actually reacts with itself. So you'll get two water molecules that bump into each other, and they'll get converted into one hydronium ion, H3O plus, and one hydroxide ion, OH minus. Now that doesn't happen at a real high frequency, as you'll see, but it does happen. So this happens spontaneously. We're not talking about like a real chemical reaction where you're mixing two things. I mean, water is water. It's always mixed with itself if you got a glass of water. But inside that glass of water, every now and then you get a couple of water molecules that bump and get converted into exactly the same amount of hydronium ion and hydroxide ion. So that reaction that you had in the warm-up is here. Now, remember conjugate acid-base pairs? How would we figure out which of these is the acid and which of these is the base? Trick question. Doesn't matter. Pick whichever one. They're the same. They're identical. But as far as the conjugate acid and the conjugate base, this is the conjugate acid because in the reverse reaction, it's donating a hydrogen to this. Since this is accepting, this is the conjugate base. Remember, that's Bronsted-Lowry acid-base theory. Now, this self-ionization, that's what this is called, this reaction, happens at a very low level. So what are the concentrations in moles per liter of these things found in water? Pretty small. Remember, for every one hydronium, you got to make one hydroxide when these two bump into each other. So the concentration of hydroxide ions has to equal the concentration of the hydronium ions, and it turns out that it's 1 times 10 to the minus 7 moles per liter. So there's not very much of this stuff, but it does happen. And it does have important consequences for acid-base type reactions. Now, because at 25 degrees you get those concentrations, chemists have developed the idea of this constant because remember it's always 10 to the minus 7 of each, and so Kw is the abbreviation for this constant. It's called the ion product constant of water. Think about it. Ions, product means multiplied together, and constant because it's always the same value. And so it equals 1 times 10 to the minus 14 at 25 degrees. Normally we write the ion product constant of water without units. So here it is again. The ion product constant of water equals the hydronium ion concentration times the hydroxide ion concentration. This is again pure water. Since we know they're 1 times 10 to the minus 7th molar each, multiply these two together and then you'll get 1 times 10 to the minus 14 molar. Now you should know from your math class that when you're multiplying numbers with exponents, when they've got the same base, so you've got 10 to the minus 7 and 10 to the minus 7, you add the exponents. Now, here's the key thing. For any acid or base that we dissolve in water, doesn't matter, within a big range, if we dissolve some acid, well, you'll still get the same product. So if you add some acid to water, this will go up, this will go down, but when we multiply them by each other, it'll still be 1 times 10 to the minus 14. Suppose we throw some base in some water. This will go up, this will go down, but when we multiply them together, it'll still be 1 times 10 to the minus 14. That's what they mean by ion product constant. It's a constant. So it's always, when you multiply these two together in water, you get that. Now, how can we use that to solve problems? So suppose we want to calculate the concentration of hydroxide ions. We got an aqueous solution that's 0.0001 molar, that's moles per liter, hydrochloric acid. Now, you probably don't remember, but hydrochloric acid is a strong acid, so all of the H will get attached to water. So our concentration is going to be shown here. First, we use this formula, but we've got the constant. We want to solve for OH, but we don't know what H3O plus is, the hydronium ion, but we get that from here. Because it's a strong acid, the hydronium ion concentration will be exactly the same as the hydrochloric acid concentration. So now all we have to do is substitute this value in for here and solve for OH. and you can see what the OH concentration is. Comes out to be 1 times 10 to the minus 10. I want you to think about this. If this is 1 times 10 to the minus 10, this is 1 times 10 to the minus 4 if you write it in scientific notation. This times this will equal 1 times 10 to the minus 14. So everything checks and it makes sense. Now, calculate the concentration of a hydroxide ion in a solution that is 0.035 moles per liter hydrochloric acid. Again, HCl completely dissociates. It's a strong acid. Here's our formula again. We're going to substitute values. The value we substitute for H3O plus is just the same as the concentration of HCl. So it's going to be 0.035 moles per liter. Hydroxide again is what we're solving for. And this is our constant. So that's just going to be the value that it equals when you multiply hydronium ion concentration times hydroxide ion concentration. Solve for OH, and then we just finish it. You can see what the answer is. It's 2.9 times 10 to the minus 13 molar. So the concentration of hydroxide is really, really low compared to the concentration of acid, which is fairly high. All right, so that's it. Now you can go ahead and do the homework. 16.1, questions 1 through 6.